Hello, my name is Lamar Carey, and this is my project or video project on derivatives. So the polynomial I chose was 2x cubed minus 18x squared plus 48x minus 38. And I also found the first derivative and second derivative, and then inputted the equation into Desmos, and this is the graph for the polynomial. So the first step was to find the extremums, and using the first derivative, by the way. And to do this, we just need to factor for x, and that I got x is equal to 2 and 4. So that means that the slope of the tangent line at 2 and 4 is equal to 0. And if you look at the cursor, this is basically I'm drawing like the tangent line, and the slope of this line would be equal to 0, and that's at 2, and then it would be right here for 4. And now we just need to find if the intervals between these numbers and after these numbers are increasing or decreasing. And all we have to do that is pick numbers in between these numbers. That kind of sounds confusing, but you get what I mean. And then just plug it into the equation and solve it. So I chose 1, 3, and 5. And when x is equal to 1, the graph would be increasing, meaning that the graph is increasing from negative infinity to positive 2. So if you look at my cursor, this is representing that. And then 3 is in between the points 2 and 4. So when I solve for x is equal to 3, I got negative 6, which means the graph is decreasing, and the slope of the line would be decreasing too. And this is representing this. And then where x is equal to 5, which is after 4, basically the rest of the graph after 4, I got a positive number again, so it means the graph is increasing from 4 all the way to positive infinity. And this is that. Okay, so the next step was to find the concavities and inflection using the second derivative. And to do this, all we need to do is solve for x to show where the change is between concavities, and that was x is equal to 3. So this is where the change should happen. And to find out if the change goes from positive to negative or negative to positive, we just chose two numbers after 3. Two numbers after 3 and before 3, so 2 and 4. And just plugged into the equation, and I got when x is equal to 2, it'd be negative, so that means it would be concave down. So from negative infinity to positive 3, the graph would be concave down. So this is representing this if you look at the cursor. So from this is about 3 all the way to negative infinity, it's concave down. And the second point, which is 4, I solved it and I got a positive number, which means it's concave up. So from 3 to positive infinity, the graph is concave up, and this is representing this. If you look at my cursor, see how this is concave up. Okay, and next thing was to find the max and mins. So, and this was also using the second derivative. So to find the max and mins, they're usually at where the graph is concave down, and that's usually the max, and where the graph is concave up, that's usually the min. So if we just use that, we could assume that the concave down, which is this, would be the max, and the concave up would be the min. But to actually solve this, all we need to do is plug in where x is equal to 2 and where x is equal to 4. And if these are negative or positive, we could assume that these are the max and mins. So when I plugged in 2, I got negative 12. So that would be the max. And when I plugged in 4, I got 12. So that would be the minimum. And the tangent line at these points also needs to be horizontal for these to be the max and mins. And as I said earlier, the tangent line at 2, x is equal to 2, x is equal to 2, and x is equal to 4 is horizontal. So yeah. And the last thing was to find the limits as x approaches infinity and negative infinity. And we also always find limits at the highest degree, and that would be 2x to the power of 3. And the easiest way to explain this basically is if you look at Desmos, x is always increasing as you go to positive infinity, and that's why it's increasing as you go into positive infinity. And as you go to negative infinity, it's always decreasing. So you can't really mark it as like a number, it's just infinity. So as 2x cubed approaches, or as x approaches infinity, 2x cubed is equal to infinity, positive infinity. And as x approaches negative infinity, 2x cubed, it can't be positive because cubed is always negative. So it'll also be equal to negative infinity. Thank you.